Okay, so here's our final form of this. We're going to use standard form if we're given any three random points on our parabola and we're trying to find the equation that goes with it. Assuming one of those points is not, say, the vertex point. Okay, so, well, here's my graph. Now, when I have these 3 points, I don't just stick those in for A, B, or C or anything like that. I have to stick them in for the x, and the x-coordinate and the y-coordinate over here. And what I'm going to get, as you'll see, is a system of equations. Okay, so here are the steps involved in solving it whenever you have 3 random points on the parabola. You're going to take your first point right there, take that first point, stick it in for x and for y, and you're going to have an equation with A, B, and C in it. Okay? Repeat that process for the next point. That's step 2. And repeat that process for the third point. That's step 3. Now you're going to have 3 equations with 3 variables. The 3 variables that you're trying to solve for are A, B, and C. So step 4 is solve that system of equations. And how are we going to solve that system of equations? Well, we're going to use our calculator, of course, and we're going to do this RREF, reduced row echelon form, and then we're going to put our answers are their equations in an augmented matrix form. So augmented matrix. And of course that's going to give you your A, your B, and your C. You have to finally rewrite your equation. Okay, so this one's a piece of work. Let's check it out. Let's see. So need a parabola here. How about this one right here with these 3 random points on it? There's my graph. All right, so let's write these coordinates down so it's easy to just put them into the equation. Oh, and let me mention this. Since we're going to put this into a matrix, rather than write this as y equals ax squared plus bx plus c, we usually have the equal sign on the far right-hand side whenever we're putting it into a matrix. So instead, write this as ax squared plus bx plus c equals y. Kind of unconventional, right? But it's going to help you out when you put it into your calculator. All right, so working left to right, this first point is -1, 5. -1, 5. Let's put that point into this equation and simplify it down. So a times -1 squared plus b times -1 plus c. All of this is equal to the y-coordinate, and the y-coordinate is 5. All right. Simplifying this, -1 squared is just 1, so that's a minus b plus c equals 5. So here's the first equation. Let's do it again with the next point. The next point coordinates are 0, -1. Plug that in. So I'll have a times 0 squared, that's going to be easy, plus b times 0, that's going to be easy, plus c equals -1. Really, you pretty much have c, because those are going to cancel out, and you just have c equals -1. All right, there's the next equation. Final equation. I need the coordinates for this point. That's 211. 211. Right. So plug in those points in. A times 2 squared plus b times 2 squared. Not squared. B times 2 plus c, all this is equal to 11. Now you don't have to write those steps down because it's pretty easy to just go, oh, I'm sticking a 2 in here, 2 squared is 4, I got 4a, plus 2 times my b, plus my c is equal to 11. So here's the last equation. So this is how I'm going to type this into the calculator. I'm going to type this in as RREF of this matrix. So the matrix across the top row, the first equation is a 1, -1, 1, 5. The next equation, there's no a, there's no b, so those get zeros. 1c is equal to -1. Last equation, a is 4, B is 2, C 1, and then 11. And then have our calculator solve this for us. It might have been a while since you've done some of these, so let's call up this calculator and give it a try. So I want to turn that thing on, clear it out, and to input your matrix, we need to go to the matrix menu. It's in blue, so hit second, matrix. And I need to scroll over here to the word edit so I can edit in, say, matrix A. The size of this matrix, it's always number of rows times number of columns. So this is a 3 by 4. And then just type in all your numbers as you see them. Okay, and then it's always a good idea to give it a visual check to make sure that you have typed in your numbers correctly. Alright, that all looks good. Now we want to quit back to the home screen. That's second mode, or quit. Now I need to go back to the matrix menu, second, x negative 1 for matrix, scroll over to the math menu, and this one is RREF. It's way down at the bottom, so it's probably faster to go down instead of up instead of down. Yeah. Hit enter on RREF. Inside the parentheses, we're going to type the name of the matrix. That's back under the matrix menu. It's matrix A, so just hit enter. And I like to close my parentheses. Enter. So, my final answer there, I can see that my A value is 4, my B value is -2, and my C value is -1. 4, -2, 1, -1. 4, -2, -1. So I rewrite my equation as y equals 4x squared minus 2x minus 1. And then finally I am finished. Whew, what a lot of work. So you probably want to practice that, don't you? You probably do. So here are a couple of them for you to practice yourself. Alright, how about this? Were these your answers? Taking these 3 points and plugging them into standard form, y equals ax squared plus bx plus c. You plug them in for x and for y, and here are the 3 equations that we get. Plugging that into our calculator in an augmented matrix and doing RREF, row reduced echelon form, I get y equals -6x squared plus x plus 7. Or at least I hope so. Number 2, doing the same thing. Here are the 3 equations that I get. Plugging them into my matrix calculator, it does some magic, and it spits out the answer y equals 3x squared minus 5x plus 8. Alright, so actually what I'm going to do here is I'm going to review those 3 methods on Geometry Sketchpad. Just talk about them in a little bit more detail. So in this little Geometry Sketchpad demo, the first one that I have here is the vertex model. It was the easiest one. So I would be given my h and my k value, so I can move this thing wherever I wanted to. Here's my h and my k, so I'm given my vertex. Now that's not enough. It doesn't define a parabola with just the h and the k, because how many parabolas have that coordinate? So for example, 3, 1, -3, 1 as the vertex. If I just move my a value, I can see that there's an infinite number of parabolas that would go through that point. So what I need is just one extra point, and it'll nail that parabola down. Now that's the only parabola I can make with those points. Okay? Now let's look at the intercept form. So here I'd be given my 2 intercepts. I can put those wherever I want to. So here are my 2 intercepts. If I just have those 2 intercepts, is that enough to come up with the equation for the parabola? The answer, again, is no, because there's still an infinite number of parabolas that have those 2 coordinates, those 2 x-intercepts on the graph. So I just need a 3rd point this time in order to nail down that graph in order to come up with the equation. Okay? And then here, finally, standard form. I don't have any specific points on the graph, So I need a total of 3 points, any 3 points, in order to come up with what the equation is for this graph. All right.